The first situation I wanted to discuss is when you have two squares, such as a squared and b squared. Now, the difference of two squares can be factored into a product of two real numbers. So a squared minus b squared is equal to a plus b, one factor, times a minus b, the second factor. But the sum of two squares can be factored into a product of two complex numbers, a plus bi times a minus bi. So let's say you had the difference between two squares, x squared and 3 squared, 9. This would be equal to the square root of the first term, which would be x. So you'll have an x in each of your factors. You're going to set up two sets of parentheses. The first term will be x. The second term will be the square root of 9, so that'll be 3. And the two factors should have two different signs between the x and the 3. So the factors of x squared minus 9 are x minus 3 and x plus 3. To confirm that this is true, we can FOIL out this expression. X times x gives us x squared. X times 3 gives us 3x. Negative 3 times x gives us negative 3x. And negative 3 times positive 3 gives us negative 9. Negative 3x and positive 3x cancel each other out, leaving us with x squared minus 9. Some other similar examples. X squared minus 25. How would you factor this polynomial? What is the square root of the first term? The square root of x squared is x, so that goes into each of the two factors. The square root of the second term, 25, is 5, so that goes into each of the two factors, and they are separated by the two different signs. Another example, x squared minus 36. What is the square root of the first term? X squared. That would be x. That goes into each factor. What is the square root of the second term? That would be 6. That goes into each factor. And they are separated by different signs. So again, the difference of two squares gives us factors that are real numbers. But if we had the sum of two squares, it's the same exact process, except our integers are imaginary numbers. So we attach an I to our integers. So for example, x squared plus 9. What is the square root of the first term? X squared. That would be x, so that goes into each factor. What is the square root of the second term? 9. That would be 3, so that goes into each factor. We multiply our integer by I in each factor, so we wind up with 3i. And just as we did with the difference in the sum of two squares, our factors should each have two different signs. I want them to be conjugates. To confirm this, we can FOIL this out. X times x gives you x squared. X times 3i gives you positive 3xi. Negative 3i times x gives you negative 3xi. And negative 3i times positive 3i gives you negative 9i squared. Negative 3xi and positive 3xi cancel each other out, leaving you with x squared minus 9i squared. And now we can replace I squared with negative 1. Negative 9 times negative 1 is positive 9. So we wind up with x squared plus 9, what we started with, thus confirming that these two are the factors of x squared plus 9. So the only difference between the sum of two squares and the difference of two squares, the sum of two squares have factors that are complex numbers, and you multiply your integer in each factor by I. So for example, x squared plus 25 would be equal to the square root of x squared, which is x in each factor. The square root of 25 is 5. That goes into each factor. Multiply each of those 5s by I. And then you separate the real numbers from the imaginary numbers with two different signs. Same with x squared plus 36. What is the square root of the first term? That would be x. What is the square root of the second term? That would be 6. Multiply the 6's by I. And then separate the x's and 6i's by two different signs. Now in some cases, the coefficient of our quadratic term will not be 1. In this case, the coefficient of the quadratic term must be a perfect square, and the square root will be the coefficient of the x in each factor. So for example, if you had 4x squared plus a squared, when you factor this expression, you'll take the square root of the first term. The square root of 4 is equal to 2. The square root of x squared is equal to x. So the first term in both factors is 2x. If the expression were 9x squared plus a squared, the square root of 9 would be 3, and the square root of x squared would be x. So 3x is the first term in each factor. In other cases, you'll have to remove a factor in order to create the sum of two perfect squares. So a common factor can be removed from each term to convert the polynomial into two perfect squares. Let's say you were given 18x squared plus 8. 18 is not a perfect square, and neither is 8. But if we remove 2 from each of these numbers, we'll get 18 divided by 2, which is 9, and 8 divided by 2, which is 4, which will give us 9x squared, which is a perfect square, plus 4, which is also a perfect square. And now we can factor the sum of the two squares the way we normally would, with the factor 2 on the outside. So let's walk through an example. Let's say you're asked to factor 4x squared plus 16 and check the answer. Step 1, create two sets of parentheses. These are where we'll put our factors. Step 2, place a positive sign in one factor and a negative sign in the other factor. And now we can continue to step 3, which is to add the square root of the first term to the left side in each factor. The square root of 4 is equal to 2, and the square root of x squared is equal to x. So 2x is the first term in each factor. And now step 4, add the square root of the second term, 16, to the right side in each factor. And the square root of 16 is 4. The next step, step 5, we want to multiply 4 in each factor by the imaginary unit I, showing us the factors of 4x squared plus 16 are equal to 2x plus 4i and 2x minus 4i. Now the last step, we can check the answer by multiplying the factors. The final polynomial must match the original polynomial, and we get 2x times 2x, which is 4x squared. 2x times negative 4i is negative 8xi. 4i times 2x is equal to positive 8xi, which negates negative 8xi. 4i times negative 4i is negative 16i squared. I squared is equal to negative 1. And negative 16 times negative 1 is positive 16. So since the final polynomial matches the original polynomial, this confirms that 4x squared plus 16 can be factored into 2x plus 4i times 2x minus 4i. Now that is how you go about factoring the sum of two squares. Let's now have you try a few practice questions. Question number 1, factor x squared plus 49 and check the answer. Question number 2, factor 9x squared plus 36 and check the answer. In question number 3, factor 32x squared plus 50 and check the answer. Pause the video answer these questions, and then press play when you are ready to begin. Question number 1. We had x squared plus 49. Step 1, we want to create two sets of parentheses for our factors. In step 2, place a positive sign in one factor and a negative sign in the other factor. In step 3, we want to add the square root of the first term, x squared, to the left side in each factor. The square root of x squared will be x, so that's the first term in each factor. Step 4, add the square root of the second term to the right side in each factor. The square root of 49 is equal to 7. And now step 5, we want to multiply 7 by I. So we get x squared plus 49 can be factored into x plus 7i times x minus 7i. In step 6, we can check the answer by multiplying the factors. The polynomial that we get must be equal to the original polynomial, x squared plus 49, giving us x times x, which is x squared. X times negative 7i is negative 7xi. 7i times x is positive 7xi, which negates negative 7xi. 7i times negative 7i would give us negative 49i squared, and I squared is equivalent to negative 1. Negative 49 times negative 1 is equal to positive 49. So since our final polynomial matches the original polynomial, that confirms that x squared plus 49 can be factored into x plus 7i times x minus 7i. So that is the answer to question number 1. Let's now have a look at question number 2. We were given 9x squared plus 36. Step 1, we want to create two sets of parentheses for our factors. In step 2, we want to place a positive sign in one factor and a negative sign in the other factor. And now step 3, we want to add the square root of the first term, 9x squared, to the left side in each factor. And that would give us the square root of 9, which is 3, and the square root of x squared, which is x. So 3x is the first term in each factor. Now step 4, we go to the second term, 36, and we add the square root of 36 to the right side in each factor. And the square root of 36 is equal to 6. And now step 5, we multiply the number from step 4, which was 6, by the imaginary unit I. So we see 9x squared plus 36 can be factored into 3x plus 6i times 3x minus 6i. In step 6, we can check the answer by multiplying the factors. The final polynomial must match the original polynomial, giving us 3x times 3x, which is 9x squared. 3x times negative 6i is negative 18xi. 6i times 3x is positive 18xi, which negates negative 18xi. 6i times negative 6i is negative 36i squared. I squared is equivalent to negative 1, and negative 36 times negative 1 is equal to positive 36. So since the final polynomial matches the original polynomial, that confirms that 9x squared plus 36 can be factored into 3x plus 6i times 3x minus 6i. In question number 3, we were given 32x squared plus 50. Neither 32 nor 50 are perfect squares, so that's the hint that we'll need to remove a factor from both terms, and that factor would be 2. When we remove a common factor 2 from each term, we get 32 divided by 2, which is 16, as our new coefficient for the quadratic term. And 16 is a perfect square, so that works. 50 divided by 2 is equal to 25, which is also a perfect square. So now we can factor 16x squared plus 25 the way we normally would. So step 2, we want to create 2 sets of parentheses for this part of the polynomial here. And now step 3, you will want to place a positive sign in one factor and a negative sign in the other factor. Step 4, we'll add the square root of the first term, 16x squared, to the left side in each factor, giving us the square root of 16, which is 4, and the square root of x squared, which is x. So we get 4x as the first term in each factor. And now step 5, we'll add the square root of the second term, 25, to the right side in each factor. The square root of 25 is equal to 5. So we add 5 to both parentheses on the right side. And now step 6, we want to multiply the number from step 5, which is 5, by the imaginary unit I. And that will give us 32x squared plus 50 can be factored into 2 times 4x plus 5i times 4x minus 5i. And now step 7, we can check the answer by multiplying the factors to confirm that the final polynomial that we get matches the original polynomial, 32x squared plus 50. We'll start by multiplying the factors in the parentheses, giving us 4x times 4x, which is 16x squared. 4x times negative 5i would give you negative 20xi. 5i times 4x would give you positive 20xi, which would cancel out negative 20xi. And 5i times negative 5i would give you negative 25i squared. I squared is equivalent to negative 1. And negative 25 times negative 1 is equal to positive 25. And now we multiply the 2 times this expression, giving us 2 times 16, which is 32x squared. And 2 times 25 would be 50. So since the final polynomial matches the original polynomial, that confirms that 32x squared plus 50 can be factored into 2 times 4x plus 5i times 4x minus 5i.